This is the video notes for Unit 4, Lesson 8, Honors, Eating Up the Lunchroom Budget. So we have a matrix here that represents the number of food items Elvira plans to order this year for the soccer team and the drama club celebrations. And note that we have added labels to keep track of the meaning of the rows and the columns. Okay, so normally we wouldn't add labels on a matrix, but we want to just keep track of what's going on. Here is a second matrix that represents the cost of purchasing each food item at two different stores. The first store is Main Street Market and the second one is Grandpa's Grocery. So what we need to do is we need to help Elvira determine how much each event would cost if all the food for the event was purchased at Main Street Market or at Grandpa's Groceries. These total amounts could be recorded in a matrix that looks like this. So it'll have a total at Main Street Market for soccer in that top left slot, a total for soccer at Grandpa's Grocery in the top right slot, and then for drama, Main Street Market total would be bottom left for C, and then for Grandpa's Grocery, drama would have a total there for D. So let's go ahead and see if we can calculate those totals. Okay, so that's our first task. So let's find the totals for A, B, C, and D. All right. Total for A. So remember, A is the total cost at Main Street Market for soccer. Okay, soccer at Main Street Market equals. So it looks like they need 8 chips at $2.50 each. So we're going to do 8 times $2.50 plus they need 7 cookies at $3 each plus they need 4 drinks at $2 each. At $2 each. So that will get us a total for soccer at Main Street Market of $49. All right, now let's switch to soccer at Grandpa's Grocery. So this is still soccer, but it's at the other store. So I'm going to say at GG. So for soccer there, they still need 8 bags of chips, but this time it's $2 each. They still need 7 cookies, and this time it's $4 each. And they still need 4 drinks, but this time it's $1.50 each. Okay, so that gives us a total of $50. Okay. Now we're going to switch to finding out the total costs for drama. So this is calculating C and D. So drama, let's say we go to Main Street Market first. So drama needs 10 chips at $2.50 plus they need 4 cookies at $3 and they need 4 drinks at $2. So their total comes to $45. Okay, and last one, let's calculate drama, the total cost at Grandpa's Grocery. So they still need 10 chips, but this time the cost is $2 plus 4 cookies, and the cost is $4 plus 4 drinks, and the cost is $1.50. Okay, so drama at Grandpa's Groceries will be $42. So we end up with this final matrix, which is the total cost for soccer and drama at the 2 different stores. So for soccer and then drama, so at Main Street Market, soccer cost $49, and at Grandpa's Grocery, soccer cost $50. For drama, Main Street Market was $45, and drama at Grandpa's Groceries was $42. So this is like our final result, our final matrix. So they want us to explain in detail how would you use the numbers in the first two matrices above to obtain this final third matrix. Well, basically what we did was we multiplied the items that we needed times the cost at each place, and then we just added together those products, right? So we multiplied our items needed by soccer by the cost per item at Main Street Market, then added those products, right? And that's how we came up with this total. If we look back up here at the two original matrices, I'm going to try to zoom out a little bit. Basically what we did was we took this row, okay, for soccer, and we multiplied it by this column for Main Street Market, and then we just added those values, those products, to get our total. And then we did it again. We multiplied this row for soccer times this column for Grandpa's Groceries to get the total needed for soccer at Grandpa's Groceries. And then we did it 2 more times to find our total cost for drama at the 2 markets. Okay, so that's how we found our totals. Okay. Let's add that. So equals total cost for soccer at Main Street Market. And then you just repeat it, right? Like I just explained. Main Street Market. Okay. All right, let's look at our next one. Number 3 says, in addition to the soccer team and drama club, Elvira plans to host events for the chess club, the cheerleaders, and the football team. She gives you the following matrix to represent food items that need to be ordered for each event. Can you use matrix multiplication with the cost matrix given above to determine the total cost of each event if items are purchased at each store? All right, so we want to do what we just did, but now we're including 3 other groups in the calculations. So can we do this? Can we multiply this items needed by our cost matrix? So let's add that in here. $2.50 at Main Street Market. That's for chips. $3 for cookies and $2 for drinks. And then at Grandpa's Grocery, it was $2 for chips, $4 for cookies, and $1.50 for drinks. So can we do this? Well, we already did this for soccer, right? We multiplied the items needed by the cost. So we actually already know some of our final matrix for total cost. So total costs. So we already know soccer and drama because we did those calculations already. We don't know chess. We don't know cheerleaders or football. Okay. So we know for soccer that when we multiplied their items by the cost at Main Street Market, it added up to $49. That's Main Street Market. We know when we multiplied soccer, the items needed for soccer, and Grandpa's grocery cost, that added up to $50. Grandpa's grocery. Okay, we know the total for drama at Main Street Market was $45, and at Grandpa's Groceries was $42. So we already know that, but the question is, can we figure it out for chess, cheerleaders, and football? I think we can, because all we need is to take the amounts needed for chess and multiply them by the cost at each store. So let's go ahead and do that. So for chess, we're going to do 3 chips times $2.50 plus 4 cookies times $3 plus 2 drinks times $2. So for chess, our total ends up being $23.50. Okay, and then we're going to do this again, but at Grandpa's Grocery. So we're going to go this row times the cost at Grandpa's Grocery. So 3 times $2 plus 4 times $4 plus 2 times $1.50, and we get $25. Okay, now we're going to do it for the cheerleaders. So we take the items needed for cheerleaders and we multiply it by the cost at Main Street Market. So 2 times $2.50 plus 3 times 3 plus 2 times 2, that gets us $18. The cheerleaders don't need very much at Main Street Market. It's pretty inexpensive. And then let's find the cost for their items at Grandpa's Grocery. So that's 2 chips times $2 plus 3 cookies times $4 plus 2 drinks times $1.50. So at Grandpa's Grocery, it costs $19. Okay, and then we're going to do football, the football team. So we've got their row, and we're going to multiply it by each of these cost columns. So 14 times $2.50 plus 12 times 3 plus 8 times 2. So for the football team at Main Street Markets, it's going to be $87. And then let's say we go to Grandpa Grocery, so it's 14 times $2, and then 12 times $4, and 8 times $1.50, and that is a total of $88. Okay, so it's definitely looking like Main Street Market is cheaper for most of the groups. The only group that is a little bit more expensive there is drama, just because of the combination of items that they got. Right, so I totally think that this was doable. And you'll notice why it was doable. Like, we added more groups, but we didn't add more items that were being bought. We were still buying just chips, cookies, and drinks, which is what we had in our cost matrix for each store. We had the cost of chips, the cost of cookies, the cost of drinks at both Main Street Market and Grandpa's Grocery. All right, so that looks good. Let's try another one. In addition to chips, cookies, and drinks, Elvira plans to add rolls and coconuts to the events menu. She gives you the following matrix to represent all of the food items that need to be ordered for each event. Can you use matrix multiplication with the cost matrix given above? Okay, so we're going to use that same cost matrix. So we're going to times it by our cost matrix, Main Street Market, and Grandpa's Grocery. Main Street Market chips was $2.50, cookies was $3, drinks was $2. Grandpa's Grocery chips was $2, cookies was $4, and drinks was $1.50. Okay, so can you use the matrix multiplication with the cost matrix given above to determine the cost of each item, of each event if items are purchased at each store? So I think with this one we cannot do it, and I'll tell you why. Do you see how she added 2 new items there? But we do not have the cost information at mainstream markets and Grandpa's grocery. Like, that information would show up down here, right? In our cost matrix. It would be like down here. We would have a cost for rolls and a cost for cold cuts under Main Street Markets, and then under Grandpa's Grocery, we would have a cost for rolls and a cost for cold cuts. So we're missing 4 pieces of information in order to multiply the matrices. So we cannot do this. So I'm going to say no. No, we can't, because we are missing cost information for rolls and cold cuts at both markets. So she can't just add more things that she needs to purchase for the events. She also needs to research how much those cost at the 2 markets. All right, let's go ahead and turn the page and do our takeaways. So this is something, our first takeaway has to do with noticing that matrices can be multiplied together if their dimensions are compatible. Okay, so let's talk about what that means. So over here in number 4, the dimensions were not compatible. We had 5 columns in our first matrix, but then over here in the cost matrix, we only had 3 rows. Do you see that? Like, the information is not compatible. We're missing information. Okay, so that's what it means when matrices can be multiplied together if their dimensions are compatible. It means that the number of columns in the first matrix has to match the number of rows in the second matrix. The number of rows in the second matrix. Okay, so this is actually really important for matrix multiplication. I'm going to go back really quick and look at number 3 to kind of illustrate this. So let's look at number 3. So in number 3, they added a whole bunch of groups to the first matrix, but they still just had 3 columns. Do you see that? And for the cost matrix, they still had 3 rows. So it was still compatible. 3 columns, 3 rows, we can still find our totals, even though we added a whole bunch of more groups to our first matrix. Okay, but here in number 4, we had 5 columns and still only 3 rows. So that is definitely not compatible. All right, let's continue our takeaways. For example, these two matrices can be multiplied together. So let's say we have the matrix A as 8, 2, 1, and then 10, 4, and 3. And then for matrix B, we have 2, 2, 3, 4, and 2, 1. Then we could definitely multiply matrix A times matrix B. Okay. One more comment about compatibility of matrices. When used to model a context, matrices can be multiplied together if their units are compatible. So that's also really important. So the items, and this is what that means. It means that that the items represented in the columns of the first matrix needs to match the items represented in the rows of the second matrix. In the rows of the second matrix. Okay, so that is really, really important. So I'm going to go back to number 3, because number 3 was an example where we were able to multiply the matrices. And I'll talk about what this means, that when used to model a context, matrices can be multiplied together only if their units are compatible. So let's go here and see what that means in number 3. So looking at number 3, do you see how our labels for the columns in this first matrix are chips, cookies, and drinks? And then the labels for the rows in the second matrix are also chips, cookies, and drinks. Like, I didn't write it here, but that's what the 250 was. It was for chips, 250 and 2. The 3 and the 4, that was for cookies. The 2 and the 150, that was for drinks. So because the items listed in my columns in the first matrix and my rows in my second matrix are the same, that means it's compatible. Like if I had, let's say, randomly, this row right here did not represent drinks. Let's say it represented hot dogs. All of a sudden, I could not multiply my matrices because the context of my two matrices wouldn't be compatible, right? I'm looking for the total cost of chips, cookies, and drinks, not chips, cookies, and hot dogs. So make sure that you're checking your context as you are multiplying matrices as well to make sure things are working. All right, let's do a little bit more for our takeaways. It says, using the matrices given above, describe and illustrate how to find the matrix product of A times B. All right, so we're just going to show a final example here without context, just pure matrix multiplication. All right, so we have A times B. Okay, A is 8, 2, 1, 10, 4, 3, and we're going to multiply that by our second matrix, which is 2, 2, 3, 4, and 2, 1. Okay, and we're going to get a final matrix over here that is the multiplication product of those two. So we're going to end up with something over here. Okay, and let's show our calculations down below. That way you have them in your notes on how to find each element in the final matrix. So we end up with a matrix that looks like this. It has an A, a B, a C, and a D. And we're going to show how to calculate each using these numbers. So to find A, it's going to be 8 times 2 plus 2 times 3 plus 1 times 2. So that is 16 plus 6 plus 2. So that is 24. Okay, and to find B, so all I did was I multiplied this row by this column, right, to find A. Now I'm going to multiply this row times this column to find B. So that's going to be 8 times 2 plus 2 times 4 plus 1 times 1. So that's 16 plus 8 plus 1. So that's going to be 25. Okay. Now we're going to find C and D. So to find C, we're going to multiply our second row by our first column over here. So that's going to be 10 times 2 plus 4 times 3 plus 3 times 2. So that's 20 plus 12 plus 6. So that's 38. And then our final one, D, we're going to find by multiplying this second row by our second column right there. All right, so that's going to be 10 times 2 plus 4 times 4 plus 3 times 1. So that's 20 plus 16 plus 3, which is 39. Okay, so we got all our totals, so now we're gonna put them in our final matrix that represents the product of A times B. So here's our final answer. So we put 24 in this upper left corner. And then upper right, we put 25. And then bottom left, we do 38. And then bottom right, 39. Okay, and that's how we got those. And put it all together in our final matrix. Okay, the vocabulary that was covered today was matrix multiplication. And then the lesson summary. In this lesson, we should have learned how to perform the operation of matrix multiplication. The row and column structure of the two-factor matrices facilitate this work. They allow us to do this multiplication since every element in the product matrix comes from adding together several partial products. So I hope that this was helpful, and I wish you good luck on your practice.